أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم وظنون إذ ذهب مغاضبا فظن أن لن نقدر عليه فنادى في الظلمات أن لا إله إلا أنت سبحانك إني كنت من الظالمين فاستجبنا له ونجيناه من الغم وكذلك ننجي المؤمنين صدق الله العلي العظيم. This is the second class of biochemistry about enzymes. Today I am going to talk about kinetic of enzyme-substrate interaction. In previous class I explained these two enzymatic reactions. In the first reaction, an enzyme acts on substrate molecule and forms enzyme-substrate complex, and in the second one, enzyme-substrate complex is undergone some change and products are formed and enzyme molecule is released. K4 is reverse reaction rate constant and is very negligible and can be ignored. Existence of enzyme substrate complex at active sites of enzymes and from which kinetic of enzyme substrate interaction were postulated by Leonor, Michaelis, and Menten in 1913. They showed that plot of single substrate enzymatic reaction rate is a hyperbola in which x-axis or horizontal axis represents substrate concentration and y or vertical axis represents velocity or rate of enzymatic reaction. This plot is also called Michaelis-Menten plot, and respective equation is called Michaelis-Menten equation, in which V or velocity or rate of single substrate enzymatic reaction is equal to Vmax or maximum rate of enzymatic reaction multiplied by substrate concentration divided by Km plus substrate concentration. Km is called Michaelis-Menten constant and is defined as substrate concentration at which the rate of enzymatic reaction is half of the maximum rate of the reaction or half of Vmax. Km depends on enzyme type, temperature, and pH. The smaller values of Km, the higher activities of enzymes. When substrate concentration is very smaller than Km value, the substrate concentration in denominator will be very small and can be ignored. So this equation is changed to this equation, and the enzymatic reaction follows first order kinetic. It means that the rate of enzymatic reaction depends on substrate concentration. When substrate concentration is very greater than Km value, the Km value in denominator will be very small and can be ignored, and substrate concentration in numerator and in denominator are cancelled, and this equation is changed to this equation. It means that rate of enzymatic reaction only depends on maximum rate of that reaction and is independent of substrate concentration. In this condition, the enzymatic reaction follows zero order kinetic. Kinetic behavior of enzymes is defined by Vmax and Km values. Michaelis-Menten plot is an asymptotic plot. It means that this curve never meets its asymptote or Vmax line. So calculation of Vmax and Km values from this plot is difficult. Thus, Hans Lineweaver and Dean Burke in 1934 introduced their plot and their respective equation. Lineweaver and Burke plot is a straight line in which 1 divided by V is depicted versus 1 divided by substrate concentration. A slope of this straight line is Km divided by Vmax, and X and Y axis intercepts are minus 1 divided by Km and 1 divided by Vmax respectively. This equation is inverse of Michaelis-Menten equation. By reciprocating both sides of Michaelis-Menten equation, you will reach to Lineweaver-Burke equation. So Lineweaver-Burke equation is called a double reciprocal equation. This equation is the equation of a straight line in which 1 divided by V represents Y, Km divided by Vmax represents a slope, 1 divided by substrate concentration represents X, and 1 divided by Vmax represents Y-axis intercept. From this plot and this equation, Km and Vmax values are simply calculated. At the end of this class, I would like to plan one question. Please answer the question. Please solve this equation to find 1 divided by Vmax and minus 1 divided by Km, namely Y and X axis intercepts. والسلام على من اتبع الهدى.